So I believe this is going to be our last section. We're going to cover literal equations. Okay. Equations with more than one variable. Equations with more than one variable. Okay, so we're going to solve each of the equations below for x. So again, we've done this since the get-go. We're going to add 5 to both sides. We're going to find out that 2x is equal to 18. We're going to divide that 2 out of there and find out that x is equal to 9. We're going to come over here. Now we're solving for x, but the problem is I've got multiple variables. There's no numbers there. So again, we're going to do the opposite of minus b. We're going to add b. Since I cannot add c and b together, we're going to write this as c plus b. To get x by itself, we have to divide that a out of there. And so x is equal to c plus b divided by a. Okay, so I can't get bound to any specific number because I just had a bunch of variables. So similarities and differences. Similarities. Here we added 5, but here we added b. Here we divided by 2, and here we divided by a. So we are still use opposite operations to solve differences. The end result of a literal equation contains more variables. Contains variables versus a singular number. And so that's what we're going to do in this section. We're going to solve, they're called literal equations. So it's going to solve for a certain variable, and we have to do that. So we have to solve for w. So we want to get w by itself. So I'm going to divide the L out of there. We're going to get w equals a divided by L. And that's it. That's all there was to it. I'm just rewriting the same equation, just in a different form, solving for the variable they asked. Okay? So here we're solving for h. So that means I got to get rid of this b. So b is attached by multiplication. So we're going to divide that b out of there. H is going to be equal to a over b. Distance equals rate times time. That's an equation that we're probably likely to see hit or miss all the way through, just because that's a common one we're going to use. Sometimes we'll solve it for a different variable. I want to solve for t. So that means I have to get rid of the r by division. So that means that time equals distance over rate. Interest equals principal times rate times time. Again, we're going to get t by itself. So the p and the r are being multiplied. So we're going to divide the p and the r out of there. So t is going to equal I divided by pr. Alrighty, we're going to solve for h. Again, this is very, very similar. I'm trying to get rid of the L and the W. So we're going to divide by L and W. So again, those are going to cancel out. Why won't this? There we go. We're going to cancel those out. So the only thing left is H. And we have V over LW. Solving for R. So this one's going to involve a little bit different. This one involves 2 steps because R is being squared, and we have to be able to undo a little bit of that. So we're going to divide by pi. And so this one looks a little bit different. We have A over pi is equal to R squared. And I'm trying to get r by itself, but we still got this r attached to it. So that means we're going to have to square root it to get rid of that r. So we're going to end up with r equals the square root of a over pi. And we'll leave our answer like that. So that was all multiplication division. In number 7 here, we're going to add the s over and add the s because it asked me to solve for c. I can't add m and s together, so I'm going to rewrite that as m plus s is equal to c. Solving for m, and it's just deciding what we're going to do. M is being divided by v, so that means we're going to multiply by v. So that means that dv is equal to m, because the v's are going to cancel. I wish I knew what GEMS stood for. Let's scroll over here and see. Does it write out? That's think backwards PEMDAS. I don't know. It'd be interesting what GEMS stood for. Here we go. So we're going to solve for h. Okay. So in some of these, like here before, we again we had that fraction in there. I'll get rid of that first. So I'm going to multiply by 2. Okay. So the 2 and the 1/2 are going to go. They're going to cancel. So BH is equal to 2a. And now we're trying to solve for h, which means we need to divide out the b. So h is equal to 2a over b. Okay. Similar thing happens here. We're solving for b. I want to get rid of that 1/3 first, so I'm going to multiply by 3. So 3v is equal to the 1/3 and the 3 cancel. B times h. We're solving for b, so we're going to divide out the h. And so that means that b is going to be 3v divided by h. And again, all these problems are going to work similar. There's multiple operations that go along with each one. Okay, we're solving for m. So I want to get rid of that fraction. So again, since I'm dividing by 2, I'm going to multiply by 2. So 2k is equal to mv squared. Again, we're solving for m, so that means I need to get rid of the v squared. So we're going to divide by v squared. So that means that m is equal to 2k over v squared. $12 is working the same way, except when instead of dividing by a number, all the other ones were dividing by a number. This one's dividing by a letter. So again, we worked this. It works similar. We just use letters instead of numbers, and a lot of times we can't put it together, and so we just write it down. Here, my d's cross out, which is what I wanted, but I have a times d, which is ad equals b plus c. Now this one is a little bit different because we're solving for b, but the c is attached by addition, so we're going to undo it by subtraction. So I had AD, but I cannot subtract the C, so we're just going to write that down as AD minus C is equal to B. All right, I think we got 6 more, and then I believe we're done. Yep, 6 more and we're done. Solving for W. We're going to subtract the 2L. We're going to subtract the 2L. So P minus 2L is equal to 2W. We're getting W by itself, so we're going to divide the 2 out of there. So that means that W is going to be P minus 2L all over 2. Solving for Y. We'll see this one again, guarantee you. So we're going to subtract the AX over. So we're going to get BY is equal to, we could write this as C minus AX, or we could go negative AX plus C, whichever way you want to do that. And then we'll divide the B out of there. And so Y is equal to negative A over B X plus C over B. Now, I actually did that one a completely different way, just because that's when we go to graph linear equations, that's what we're going to do. It would have been totally acceptable to write this as negative AX plus C all divided by B. In this section, that's what probably I would expect you to do, would be to do it that way. It's just I'm so conditioned to do this just for linear stuff that we're going to do in a couple of chapters that I just automatically did it. I wasn't even paying attention to what I was doing. All right, so here we go. Solving for X. It continues. The second verse, same as the first. This is just a lot of examples. MX. I'm trying to get X by itself. So we're going to divide the M out of there. So Y minus B divided by M is equal to X. We're going to solve for T. So we're going to have to subtract this P. Now this one's a little bit different. It's got two P's in it. But luckily we didn't have to solve for P. We'd have had to use a property that we haven't discussed yet. All right, so we subtracted the P over. To get A minus P, we have PRT left. We're solving for T. So that means I need to get rid of the P and the R. I have to get rid of the P and the R. And so we're going to leave our answer like this. I know a lot of people want to cross out that P's, but we can't. We have to cross out like factors, not like terms. So we're going to be stuck with that. All right, and then it looks like we're going to take a couple of the Celsius to Fahrenheit, or Fahrenheit to Celsius conversion, and then we're going to work with the area of a trapezoid, it looks like. We're going to solve this for F. Here, again, this is something we've talked about before. I'm going to multiply by 9 because I don't want the denominator, actually, but I'm going to multiply by the entire reciprocal of 9/5. So that whole thing goes away. My 5 cancels. You can't see that. My 5 is going to cancel out here. My 9 is going to cancel out here. So that means that we also have to then multiply with this side by 9/5. So I end up with 9/5 C is equal to, everything canceled out there, so this is just F minus 32. So now we'll add the 32 over, and now we have the conversion from Celsius into Fahrenheit. Okay, Fahrenheit is 9/5 Celsius plus 32. All right, and so again, this is something that we're going to see down the road. You should take a physics class, a chemistry class, something to that. This has a lot of science applications to it because we have to solve for other variables. Okay, in this last example, we're trying to get B1 by itself. B1 is here inside the parentheses, so that means we have to get rid of all that stuff. So I have to get rid of the 1/2 by multiplying by 2. So we have 2A is equal to H times B1 plus B2. Now here typically we distribute and we could distribute that. However, I don't necessarily want to do that. Okay, I'm just going to divide out the H and divide out the H. So we have 2A over H is equal to B1 plus B2. And again, we're trying to get B1 by itself, so I have to subtract away the B2. And so we end up with 2A over H minus B2 is equal to B1. And so we've conquered that. So I don't know how long that took us, but I don't think very long, but to do those 18. That's solving a literal equation. It's just rearranging the deck chairs because we're still stuck with a bunch of letters. So, all right, have a good one.